So we are looking at A1.13, and we're doing two methods. The first one is going to be elimination method, and the second method is going to be substitution. And then at a later day, we are going to do graphing. Okay? Now, what am I talking about with systems? These are both in that standard form. And we talked about standard form before. Standard form, not that you have to know this, but just to bring it back, is the ax plus by equals c. Okay, so it doesn't really matter that they're in standard form because we're not graphing them. But if I was graphing them, I'd want them to be y equals mx plus b, right? So standard form has x's and y's on the left and a number on the right. So there's your ax plus by equals c. That's what we're looking at, but we're not worried about that. We want to use this thing called elimination method. Now let me back it up a little bit. Before I talk about elimination method, if we're talking about a system of equations, we're talking about trying to figure out where two lines intersect. So let's say I have a graph, and again, you don't have to write this down. I just want to bring this full circle. Let's say we have a graph, and I have one linear equation that looks like this, and then I have another one that looks like this. The idea is two lines will only intersect at one point, which is right here. So maybe that one point is 2, 3. You guys have seen this before. So if they intersect at this point at 2, 3, that's my solution. Now, two lines intersect at one point. Now, there's two other things that can happen when two lines are graphed. You could have parallel lines. If my lines are parallel, how many places do they intersect? They don't intersect at any. So that'd be like the no solution. Remember how when we had those untrue statements, we said we can't solve it? Well, this means in this case, we don't have an ordered pair that they both have in common. Now, what if my lines are the same? It's called coinciding lines. So if I graph the line and the other one was the same line, how many solutions do I have? One. Actually, infinite solutions. Because it's not that I can pick anything, but any point on one line also works on the other line. So typically we have one solution because lines aren't coming back around. We typically have one solution, but you can have special cases where they never intersect because it's a false statement or parallel lines, or they're the same line. Okay, so we have those special cases. Now, how do I do elimination method? Some people call this the addition method or addition subtraction method. Elimination method is basically you getting a variable to cancel if we would collapse these. So I'm going to put a line under here. I like to use the idea that I'm always adding. Our goal is to eliminate a variable. So if I would add these down, I would get 6x minus 3x, which is 3x. But when I add the 5y and negative 5y, what happens? They cancel. I have 0 y's. And then that equals 20 plus 10, 30. So we eliminated the y value, and that doesn't just magically happen. We have to have one positive and one negative of the same thing. Do you see what we did? This one was all set for us, and then I can just simply solve for x by dividing both sides by 3. And what does x equal? 10. Now, typically we're done. We found x, but this has two variables, right? We want to solve giving ordered pairs. So I have to do a little work now. If x is 10, I need to find y. So you can pick the first or second equation. It doesn't matter. I'm going to pick the first one. I'm going to put in 6 times 10 plus 5 times what I don't know y equals 20. So this is another reason why we did some practice on solving equations. So I'm plugging in what I know to solve for my unknown. Following the order of operations, multiply 60 plus 5y, and then start solving. So what would I do first? To solve it, subtract 60. And this should cancel, and I get 5y equals negative 40. And my last step is to do what? Divide both sides by 5. So y equals negative 8. Oh, you can't see it? All right. Final answer is an ordered pair. I'm going to write it up here. X is 10, y is negative 8, and I'll make it real obvious. Now, how do I know if I got this right? I would take the x and y, I would plug them both in and make sure that I actually got out 10. Okay, now, number 2. Take a minute and look at that. If I add these x's, will I cancel them out? If I add these y's, will they cancel out? Okay, so I have to do a little bit of extra work. Any interest on what you want to do? Okay, now what was your goal? Did you want to cancel the x's or the y's? I know this one's a little bit different, but what was your idea at first? To cancel x or y? Okay, it does not matter which one you get rid of. So you were saying multiply by -1. Did you want to multiply the top one or the bottom one? Okay, so it does not matter. We could all do these problems a little bit differently, but I agree this would be one of the quickest ways to do it. You were targeting to get rid of the y's. Now, I'm going to rewrite this. Everything gets multiplied by -1, but the big mistake is people forget to multiply the other side. So -1 times 8 is positive 8x. -1 times 8y is negative 8y, and then equals positive 16. Now, by doing that, I now have a negative 8y. I don't have to change the other equation. Sometimes you just have to change one. So your goal was to get the y's to cancel, and we did that. But what else happened? Yes. So whenever we're looking at this, you meant for this to cancel out, but this actually gives me 0, and 16 minus 16 is also 0. So it's good to write down what we actually got. It's not x. X isn't 0. 0 equals 0 is a true statement, right? So you're right. It's all real solutions or infinite solutions. These lines are the same line. So that's my final answer. Now, I can't pick a random ordered pair. It has to be something that the x and y make -16. But anything that works in the first equation works in the second. Wow. All right, look at number 3. Now, are you noticing that these sort of step up each time? Like the first one just canceled out. The next one, we just changed one sign for the one problem. On this one, does anything cancel? Okay, you have two options. There's an easier option and a harder option. So I want you to think about, you think about what you'd want to do to make one variable zero out. All right, so what do you want to do? Did you want to get rid of the x or get rid of the y? Okay, if I was doing it the quicker way, I'd get rid of the y. Here's the deal. This is a 6. What can I multiply this by to get rid of 6y? Not 6, but -6. So if I can use this, then I only have to change one equation. So now back it up. How else could I have done this? Well, what's a common multiple of 5 and 2? What can I get? 10. So I could multiply the top by 2 and the bottom by -5. And then do you see that that would work? But if I have a y that can build to the other y, I might as well use it. Now, don't forget, -6 times 5x is -30x. -6 times y is -6y. And -6 times 11 is -66. So take a minute and make sure you get everything, or if it helps you, put it over here. The bottom one we didn't have to change because we made one positive and one negative of the same number. That's your goal, to get one variable to cancel. So I am really just vertically adding to get -28x. This is gone. Double check that you really do have the right signs. And then -66 and -18. Is that going to cancel, stay negative, positive? What do we get? Yeah, it's two negatives when you're adding. They're going to add the numbers, keep the negative sign. All right, I'm going to divide both sides by -28. And you're telling me x is 3? Okay, now that's the x value. What else do I need to find? The y value. Again, you can plug into either equation. I normally go back to the original, and I'm going to pick that top one. 5 times 3 plus y equals 11. All right, now some of you can skip a step and just subtract 15, but it's 15 plus y equals 11. Subtract 15 from both sides, and what does y equal? -4. Final answer as an ordered pair would be 3, -4. Now, it just happens in both of these we solve for x first, but guys, you could solve for y first and then go back and find x. All right, look at the next one. There's not going to be a quick way to do this one. We're going to have to deal with both equations. So when you are looking at this one, what would be a common multiple of 8 and 6? 24. And we want to find the least common multiple. Could you make it bigger? Yeah, but why? So if you wanted to get rid of the x, we'd multiply this by 3 to get positive 24. And multiply this by what? A negative 4. Do you get the idea that if you don't have a negative sign, you need 1 to be negative? Now, I'm going to do that. But if I didn't want to get rid of the x, what would my least common multiple to be for the y's with 6 and 7? I'm thinking 42. I can't think of anything else. Can you? So we'd have to multiply this by 7 and this by negative 6, or vice versa with the negative signs. All right, we're going to go ahead and do this with 3 and do this one with 4 that's negative. I don't care which one you make negative. It's up to you. Distribute to all three things. 24x plus 18y equals, I'm going to go with negative 78, but someone should check me. Anybody agree with that?
Yeah.
All right, then the bottom, change your signs. Negative 24x minus 28y, whoopsie daisies, equals negative 40, and I think it's negative 68.
Yeah.
No, positive 68, right? Negative times a negative?
Positive.
All right, we agree with my numbers?
Yeah.
And I would be double checking myself if I was doing this on my own, because if you mess up one number, everything changes. Our goal was to get rid of the x, add up the y, so positive, negative cancel. I should have negative 10y equals what? Negative 10. Divide both sides by negative 10. And all of that work, what does y equal? Y equals positive 1. All right, what else do I need to find? Okay, so what do you want to do? All right, so you're going to take that y. You want to put it in the first one or second one? Your choice. First one? Okay. So 8x plus 6 times 1 equals negative 26. All right, well, we know that 6 times 1 is just going to be 6, so I'm going to go ahead and just subtract that. So I have 8x equals negative 32. Well, that's nice because I could divide by 8, and what does x equal? X equals negative 4. Okay. Ordered pair? Yeah, and make sure you're paying attention. The x is first, so pull your x and then pull your y. There's our final answer. All right, that's elimination method. Now we're going to switch gears and go to substitution method. You ready?
So ready.
Yay.
All right, so here we are with substitution. Now, with substitution, you are going to take one equation and actually put it in another. Substitution, you need one variable solved for. One variable solved for. And what I'm saying is solve for is as in I need to have an x equals or y equals. Now, what's weird about number 5 is I have both of them. Both of them say y equals. Here's what I want you to think about. If y equals x minus 9, guess what I'm going to do? I'm going to put it in here and replace that y with it. So instead of having a y there, I'm going to put the x minus 9 equals negative 2x plus 9. So I know it looks weird, but if y equals this, and y equals that, shouldn't these equal each other? That's what we're doing. So, or I took what this equals and I substituted in. Now we need to solve. The difference here is I have variables on both sides. Agreed?
No.
So what do you want to do? So I'm going to add my 2x over, but you could go the other way. So now I have 3x minus 9 equals 9. Now, remember, you could put a 1 here. And then I'm going to move my 9 over by getting it added up here. And I get 3x equals 18. So what's x equal? Divide by 3. Yep, x equals 6. Okay, what do I still need to solve for? Y. Now what's nice is both of these say y equals. So which one do you want to use? Second one, yeah, has less stuff. So y equals, and it would be 6 minus 9. So what does y equal? Negative 3, yeah? Okay, so I'm going to come back up with my ordered pair. 6, -3, and there it is. Okay, now that one had a y equals and another y equals. Look at number 6. It actually also has a y equals. So as long as one variable is by itself, I'm good. I'm going to circle this. I'm asking you guys to do the same thing. So whatever I have, if I have y equals this, I want to circle this and I'm going to point to where it's going. So whenever I have kids come up to me, they're like, I don't even know where to start. The minute I have them start circling and pointing, it makes sense. So we are going to keep that 4x. We're going to keep the -2, and you need to use parentheses. I'm replacing the y with what it equals, which is 3x plus 8. And that is now equal to -10. Okay, do you see what I did there? I took what y equals and I put it in here. Every time you place a variable, get in the habit of using parentheses. Now, I've got a little cleaning up to do. That's why we practice this. When I distribute, I'm distributing it a -2. So there's -6x and -16. All right, before I start moving things, and a couple of us have talked about that, some people were moving all kinds of stuff. Let's add like terms. What's 4x minus 6x? -2x. We're not crossing the line. We're not changing the signs. So -2x minus 16 equals -10. And now we've cleaned it up. So start solving. What do you want to do? Add 16. Okay. All right. This cancels. I get -2x equals what? +6. And so what is x equal? Divide by -2. X is -3. Okay, I still need to find what? Y. All right, now you could plug x into either equation, but if I'm trying to find y, maybe I want to use the equation that says, I don't know, y equals. So here we go. Y equals 3 times -3 plus 8. Okay, I plugged it in. Use my parentheses so I didn't screw it up. Y equals -9 plus 8, so y equals -1. Okay, what's my final ordered pair? X is -3, y is -1. There we go. Okay, I'm going to say it again, but I want to show it this time. If you were doing this and you want to check your answer, I would take my answer and plug it in here. I'm just going to use my calculator. So I'm going to do 4 times -3 minus 2 times -1. And I should get out -10. I should be able to plug that x, y in and get out the answer they gave me. That's how I know it's the right solution. Now, what else does this mean? If I would graph these lines, that's the point that they have in common. Now, this is not the right graph, but if I graph two lines, the point they have in common is the point that we just found here. Okay, now I go to number 7. I said you need to have a variable solved for. In 7, they're both in standard form. Do you see that idea? So a lot of us might want to do elimination method, which would be quick if I multiply by -2. However, the directions say to use what? So you have to follow that. Now, I need to solve for a variable. What would be the easiest variable to solve for? X or Y, first equation or second? And pay attention to this because we can make it easier.
Y.
Okay, I'm hearing y in the first equation. Okay, so why do you want to solve for y in the first equation? Because you could have solved for x or y down here. You have to do more stuff because y has a coefficient of 1, right? So if I can find something that's a little bit easier, then I'm going to solve for this. Now, let's say this had a 3 here. It didn't matter what I'd solve for. I'd have to move things and divide. But I'm going to solve for this y. Now, when I go to do that, what do I have to do? So I have -7x plus y equals -1. I'm going to take this whole -7x and add it to the other side to get y by itself. So I get y equals what? How do you want to put this? You could do it as 7x minus 1. You could do it as -1 plus 7x. Okay? All right, well, now that we know that y equals that, should I solve this equation for y? Nope. You only need to solve one for your variable. And now that I know that y equals this, guess what I'm going to do with it? I'm going to take it and I'm going to plug it into the other equation. So you do need to pay attention to what you're doing. I solved the first equation for y. Now I'm going to take what y equals and plug it in here. So keep your negative 14x plus 2, keep your y equals negative 8. But what am I putting inside the y? 7x minus 1. Okay, I've got a little work to do before I can solve this. And that would be negative 14x plus 14x. Uh-oh, anyone seeing anything here? Yeah, when I go to clean up, these are going to cancel, and I get negative 2 equals negative 8. A lot of people just stop here. But this next step, negative 2 equals negative 8, is that ever going to be true? So you would cancel this out, and you're going to tell me no solution. So you could use the null set, or you could use the term no solutions. I will take either. So you're not going to find an ordered pair. If there's no solution, that's because your lines have the same slope and they're parallel. Okay, last one. What would be easier to solve for, the x or the y? The x. So it does not matter what variable you solve for. Just find the easier one. Okay, so we're going to pick this one. X minus 3y equals negative 23. You don't have to rewrite it, but I just want to show I'm going to move the 3y over by adding it. That leaves me x equals, and you could write it as negative 22 plus 3y or 3y minus 23. All right, I'm going to fix that. All right, are we okay with this idea? So if I know what x equals, let's circle this. And where am I going to put it? I'm going to put it in x for the second equation. I really do think circling what we have and showing where it goes is really helpful. Okay, so we transform the first equation so we can plug it in. This is going to be negative 5. Now here's the other thing I like to do. I like to replace what I pointed to with parentheses, finish my equation, and it would be minus 7y equals negative 17. Now what goes in here? The 3y minus 23. What I found though is sometimes people put the stuff in and they totally lose more of the equation. So it might be worth writing your equation and then doing that. Okay, so we have some distributing to do. Negative 15y plus 50 and 15. I think it should be 65. Does anybody agree with that? No. You don't agree?
Wait, I thought it was 23.
What is wrong with me? All right, is this right? 23? So is that why you disagree, or are you just saying you disagreed because it sounded good? All right, so it should be 3y minus 23. And what do we get here? 115? All right, good catch. Thank you. All right, now I'm going to go add like terms. Don't cross the line. Don't change a sign. So I'm looking at it being negative 22y plus 115 equals negative 17. Then what? Subtract 115. So negative 22y equals, I want to say negative 132. But you should probably double check me. Anybody? I don't know. I just added 15 and another 2. Divide both sides by negative 22. Yeah. And then what do we get, guys? 6? Yep, that seemed reasonable. So what do we find? We found y is 6. Now, what else do I need? Okay. Now, you could go back to the originals, but didn't we make an equation that said x equals? Oops. So the idea is make your life easier. We solved for the variable that was almost by itself. And then why not? If we need x, we have an equation that says x equals. So x equals 3 times y, which is 6, minus 23. All right, well, that would be 18 minus 23. What is x? Negative 5. Okay, so what's my final ordered pair answer? A little messy here. The x is negative 5. The y is 6. And there we go. So 2 methods, substitution and elimination.